Welcome to the second part of nutrients and their use in the animals' bodies. We're going to be talking about the rest of the nutrient classes in this one. Lipids are an extremely concentrated form of stored energy. And when we're talking about lipids, we're talking about forms of fat in the animal's diet. They're an excellent source of essential fatty acids. There are a couple of fatty acids that animals require from a health and well-being standpoint that are precursors for other fatty acids that are important. When we talk about what a fatty acid is, they are composed of different length chains of carbon and a glycerol backbone. And in general, you've probably heard the terms saturated versus unsaturated fats. It simply refers to how many double bonds are in a fatty acid. And so generally saturated fats are solid at room temperature, such as if you think of margarine is actually saturated oil. So those are solid at room temperature. Animal fats, if you've ever used bacon grease or seen bacon grease, it solidifies at room temperature. That's because it's saturated. Oils are liquid at room temperature, such as if you look in your kitchen cabinet, olive oil or a vegetable oil, those are liquid at room temperature. Don't ask me what coconut oil is because it goes back and forth, so I'm not sure. Microbes in the rumen, they can actually alter dietary fatty acids. One of the reasons that animal meat products, such as from beef, lamb, or goat, is generally a little bit higher in saturated fats, it's because the microbes actually saturate any dietary fatty acids that come into the rumen, and so the animal deposits saturated fats. One of the things that's important about lipids and fat metabolism and fat and utilizing fats in diets is we also need to understand that a lot of times in an animal's life, one of the key times is during lactation, we actually expect them to draw on their own body fat through a process that we call mobilizing fat, and they will use that stored energy in the form of fat in their bodies as an energy source. One of the problems if it happens too fast is actually called ketosis. However, there are a lot of times as nutritionists, we actually expect the animal to use body fat as an energy source. Classic example is the high-producing dairy cow. She actually can't consume enough feed early in her lactation to be able to meet her energy needs and will have to mobilize body fat. However, we get her caught up on her ability to consume feed and grow her intake, and her requirements come down a little bit, she will be able to handle it just fine. But there is a brief time that she is expected to utilize her body fat. Minerals are inorganic elements, meaning they don't contain carbon. And so these are some of the metals, for example, copper, iron, stuff like that. We have two classes involved in feeding livestock. The major or macro minerals that are required in large amounts or percentages by the body. So just make a note that macro and major, they're required in percentages. The minor or trace minerals are required in units such as parts per million or parts per billion, very small amounts. It doesn't relate, the classifications do not relate at all to importance in the body. It's simply the quantity needed. Minerals are critical in biochemical reactions throughout the body. They're heavily involved in nutrient transport, the development of hormones, even the synthesis of vitamins. The nervous system requires minerals in various forms. pH balance and homeostasis of the body is directly related to minerals. And if we think of just the basic skeletal structure or muscle structure of the body, we've all heard that things like calcium are important for good bone development. It's absolutely true. Minerals have a key role in the structure of the animal's body. Vitamins, on the other hand, are organic substances. They do contain carbon. They are required in very small amounts in the body, but very, very important. We have two classifications, which is just relating to how they're absorbed and carried throughout the body. We have the fat-soluble vitamins, A, D, E, and K, And these are actually stored in the fat tissue or adipose tissue of the body, and as a result can sometimes build up to toxic levels. These don't require as much dietary supplementation in some species as the second class, which is the water-soluble vitamins. That includes all of the B vitamins, and there's a bunch of them, and vitamin C. Those are stored with the water supply in the body, which, as you can imagine, flushes out on a consistent basis, and so we do need to supply water-soluble vitamins to several of our food animal or several of our non-ruminant species, in particular pigs and poultry, and they do have a requirement for the water-soluble vitamins. Most of the water-soluble vitamins are very important cofactors for enzymes and are extremely important in energy metabolism. If you look on the back of any of your energy drinks or energy supplements that you sometimes take, you're going to see a lot of the B vitamins, niacin, riboflavin, B12, those types of things on there because of their role in energy metabolism. Vitamin A is important for vision. Vitamin D works with calcium and phosphorus in bone development. Vitamin E functions as an antioxidant and works with the mineral selenium in the immune system. Vitamin K is critical for blood clotting and helping the body to heal from that standpoint. I didn't put vitamin C on here, but it's actually an antioxidant as well. And so vitamins are not required in large amounts, but are extremely important in the body. We're going to wrap up the second part of the video talking about energy. And throughout high school, junior high, you've heard about energy as that ability to do work. For our animals, their work is growing, producing, being companions, whatever the case may be. And they require energy to do that. And energy, remember, is not a nutrient itself. It's derived from carbohydrates, fats, and proteins. And in the U.S., we measure energy in calories. And we're going to either talk about, when we talk about animal requirements a little bit in a few weeks, we're going to either talk about mcals, megacalories, or kcals. 1 kcal is 1,000 calories. 1 mcal is 1,000 kcals. And so, depending on the size of the animal, the larger species, such as cattle and horses, will use mcals. The smaller species, such as poultry, pigs, sheep, etc., will use kcals. Energy, different species describe energy in different ways. To understand energy requirements in animals, we need to understand how energy is described. Animals can lose energy in 4 different ways. Animals can lose energy through feces, which is undigested food, so there is energy associated with that. They can lose energy through gas and urine, which contains some energy, or through heat production out of the body. And so energy can be lost these 4 different ways. As a result, we describe energy requirements in the animal's body differently. And so when we start off feeding an animal, we actually start off with what we call gross energy. That is simply the amount of calories that is in any given food we give an animal. When you look on the back of any kind of food that you buy and you look at the nutrition label, the calories represented there, that's the gross energy. It doesn't tell us anything about how an animal utilizes energy. It just simply says, here's how many calories it has in it. Now, if we take into account that fecal energy loss, how much energy is lost in the feces, and subtract that from the gross energy, what we're left with is what we call digestible energy. And that's what we're assuming gets used in the animal's bodies. Horses are an example of a species that use digestible energy as a measure of how they express energy requirements in the horse. They try to account for that fecal energy loss and consider digestible energy as how they balance horses' diets for energy. Next, if we were to account for not just the fecal energy loss, but again the gas and urine losses, then we're left with what we call metabolizable energy. And that is a common measure that's used in pigs and the poultry industry to measure energy for these animals. The reason is because the gas losses in pigs and poultry can be high, as well as the urine loss of energy, and they feel that it's a more descriptive way to be able to describe energy use in these types of animals or birds. And so those two species use what we call metabolizable energy, which accounts for 3 of the 4 losses of energy by animals. Finally, we have the last energy loss accounted for, the heat increment. And that leaves us with what we call net energy. All losses have been accounted for through feces, gas, urine, and heat. We're left with the energy that's really getting to the tissue. And when we're talking about net energy and getting to that tissue level, it can be used for 3 different things, either maintenance, gain, or in the dairy cow, lactation. And this is used in the ruminant species because ruminants have a tremendous amount of heat that they give off because of the microbial fermentation, and they lose a lot of energy through this heat increment. And so that's why ruminant species express their energy requirements in net energy. And so we will be working with all digestible energy, metabolizable energy, and net energy, depending on what species we're talking about. So it's important to understand which terms and energy terminology is used to express energy requirements for the different species. There is another system that helps describe energy that was used in the ruminant species and even in the equine species a little bit. It's called TDN, or total digestible nutrients. And it's essentially a percentage of the diet that gets digested by the animal. It's very comparable to digestible energy, or what we call DE from the previous slide. It's simply an estimate of energy. So if you see a TDN value for a feed that is 70% TDN, what's that saying is about 70% of that feed is disappearing in the animal and assuming to go to energy. And so an example of some of our high energy feeds, like the cereal grains, can contain 85 to 90% TDN. They're very highly digestible, and a lot of that can go to energy. This is an older system, but it still has value, and we will still do some ration formulation using the TDN system as well, because it's very practical and easy to understand. When we talk about animals' energy requirements, they're also affected by a lot of different things. An animal's age, species, what level of production are we expecting from them, the environment around them, and the rest of the nutrients and how they're balanced all can affect how much energy an animal requires. And so when we delve into the animal requirements, we will be exploring how these different parameters can affect energy requirements in our animals of interest. This wraps up the second part of the nutrient discussion. Be sure to continue on and watch the third and final part of nutrients and their metabolism.